Okay, let's look at this question. Knowing that P is known and Q is known, Q is 0 and P is for 11 pound. Determine for the frame and loading shown the reaction at D. He wants the reaction at D. D is a hinge, dx dy. And A is also a hinge, ax and ay. So you need to find D, find the reaction at D, the force in member BF. Member BF, the force. So you want the force in member BF. Okay. Let's do the whole frame. We'll put the forces P and other Q is 0, and AX and AY, and DX and DY. You have two options. Either you take moment at D equal to 0 and find AX, or summation of moment at A to find out DX. So summation of moment at A equal to 0, you could find DX equal 959 pound. To apply equilibrium, we have to find summation of force at X equal to 0. Remember, here there is nothing else in the X except dx and ax. So we found dx, we could find ax by doing summation of forces at the x. So summation of forces at x equal to 0, ax equal dx, so ax is equal 959 pound to the left. So now, let's go and find out the other member that we were talking about. This member, A, B, C, because you need to find out the force here. A, B, C. Remember, there is a force here in B, and there is the reaction here is known now. So AX, AY, and there is a force FBF, and there is a force FCE. And there is a force at the top, 411 pounds. First of all, let's find the angle. It's either you find the angle or you do it using the other way around. Now, you have, this is, from this, it's 22.5, and this is 12. So you could do it using that, or you could do it using the other one. So let's look at this member, A, B, C. Remember that B has a reaction down, a tension down, and this has a tension down, and there's a force here. So we'll do it like this. A, B, C. There's a force 411, and there is a force here, the force BF, and you should know the angles. We could do it like this. This is distance and this distance. You could do it from the actual one. This is 22.5, 12. So 22.5 and 12. So you could do 22.5 square plus 12 square, all under the square root. This is 25.5. So you could make it 25.5 here. This is force FBF. Same thing for force CE. For CE, it's 22.5 and 12. No, CE is from here to here. CE is this one, 16 and 12. 16 and 12, of course, you should do the same thing, 16 square plus 12 square, all on the square root is 20. So we have it like this. So we could either assume this one tension or compression, whatever way of doing it. Summation moment at A equal to 0. This in the x-axis is 0, and this is in the x-axis 0. So FBF in the minus. Summation moment at this, it's going to take it like that. And summation of course, 12 over 25.5 times this distance, 12 inch. And FCE, it's going to take it like same way, negative, minus FCE, 12 over 20, 12 over 20. Times this distance, perpendicular distance, and also minus 411 times 28, the total distance. You would get an equation with two unknowns, like that. Now let's take the second part. Let's take this one, D, assume it's tension. This is going to be tension and tension here too. Okay, so we'll do it like this, DAF, and we'll have the same dimension, FEC, FBF, and there is no forces here. Force here is 0. Okay, so we'll do summation moment at D, so we'll have the reaction equal to 0. So FCE is equal minus 2.255 FBF. Now we have two unknowns, two equations. We plug in this, FCE is equal minus 2.25 FBF. We plug in FCE here, you could find FBF. So you'll end up with FBF is equal 357 as tension. And FCE is 805 bump tension. Now once we found this, we found FBF and we found FCE. Now we should find out the reaction A by doing summation of forces at, we could even do this one, find D and dx and dy. Which one he wants? He wants to find the member in BF, force in member BF, and the reaction at D. So we should take the last one, dx and dy, since we have it like that. We find this, we find this. So summation of forces in the y, we could find dy, and summation of forces at the x, you could find dx. So that's very simple. Thank you.